All right, so in this episode, we are going to eventually talk about completing the square to solve for quadratics. But before we get to that, I want to talk about perfect square trinomials because that will lead us into completing the square for quadratics. First off, let's remind you what a perfect square is. Perfect square is anything multiplied by itself. So if I talk about 1 times 1 squared is twice, that's 1 squared. So 1 is a perfect square, 4 is a perfect square, 9 is a perfect square, that's 2 times 2, 3 times 3, and so on and so on. Whatever multiplied by itself is a perfect square. Now, remind you, we've also talked about perfect square binomials. So if I gave you x plus x, or x plus 1, and that's squared, that's a perfect square binomial. Okay, well, how do I know that it's a perfect square trinomial? Well, the way that we can identify perfect square trinomials is when I take this, let's say I have just a general perfect square binomial that's a generic, so a plus b, okay, and we're going to square that. All right, so if I take that and I FOIL that out, all right, so that's going to give me a squared, or not a squared, that's going to give me a plus b times a plus b. All right, well, if I FOIL that, that's going to give me a times a, which is a squared. And a times b is going to give me plus ab. And then we have b times a, which is going to give me another a plus b. And then b times b, which is going to give me plus b squared. Now note, how many a, b's do I have here? I have 2 of them. So that's going to give me a squared plus 2ab plus b squared. Okay. Well, the way that I can identify a perfect square trinomial is what I know when I trinomial that I have. Because this final version here, that's a perfect square trinomial. This is a perfect square binomial. Okay, so we're talking specifically about perfect square trinomials. Well, I want to look at my c term. Remember, this is still in the form of ax squared plus bx plus c. Okay, I want to look at my c term, and I want it to add up to my b term. So if it's a perfect square that adds up to my b term, then I know it's a perfect square trinomial. So let's look at a couple of examples that I'm going to give you. So x squared plus 8x plus 16. Okay, well, 16 is 4 times 4. All right, well, if I take the factors of 4 and add them together, that will give me 8. So 4 plus 4 gives me 8. So I know that my perfect square binomial, the factored form, remember we're going to the factored form. We need the factored form in order to solve for the quadratics, in order to solve for the x variable. All right, so in order to find the factored form, we're going to take that term. We're going to look at this term to see if it's positive or negative. Okay, if it's positive, then I know that my perfect square binomial in factored form is going to be x plus 4, and that's going to be squared. Okay, let's take another one. So let's look at the next example, which I'm going to give you is x squared minus 18x plus 81. Now, here's a key comment here. We can have that be negative. If that's negative, then that just means that our binomial, when we put this in binomial form, that this term here in the middle, it's going to be subtraction instead of addition. Okay, that's the only difference. The one that can't be negative is this here. That can't be negative. If I were to give you x squared plus 18x minus 81, that is not a perfect square trinomial. So be very careful. Watch for that. That's like a key, test to see if you know what you're doing. Okay, so now let's look at the 81 is a perfect square of 9. 9 times 9. Well, negative 9 plus negative 9 gives me negative 18. So I know this is going to be x minus 9. Okay? Now, let's look at these a couple problems and let's talk about solving the equation or a quadratic equation that's a perfect trinomial and solving for x. Okay? Now, a really easy problem, let's say I were to just give you the perfect square trinomial, x squared, just like we did, x squared plus 2x plus 1. And in order for me to solve this, I need to set this equal to 0. Okay, that's not too bad. I know that this left side is a perfect square trinomial, all right? So I know that this is going to be x plus 1, and that's going to be squared, and that's going to be equal to 0, okay? Now, I'm going to take the square root of both sides, all right? Well, when I take the square root of both sides, that's going to give me x plus 1. The square root and the radical cancels out there. Square root of 0 is just 0. So that's going to be x plus 1 is equal to 0, okay? Now, that's going to give me its final solution is that x is equal to negative 1. And we can have that. Now, remember, in this case, there's only one answer, not two answers. Well, technically, there still is two answers, but it's twice. It's doubled. So that means that it's negative 1 and negative 1. This is if I were to graph this, and I were to put this on my graph, that means that I would have a vertex. My vertex would be here at negative 1. Let's say this is negative 1. That would be my vertex, okay? So that 0, that makes it my vertex. My vertex is at 0, negative 1, 0. Vertex is at negative 1, 0. And our axis of symmetry is through x is equal to negative 1. So tying that back in. Okay, now let's talk about another step where it's a little bit more complicated in terms of solving for the x values. Let's say I give you a problem that's like x squared plus 4x plus 4, and that's equal to 25. Okay, well, a couple of things I'm going to notice here. One of the things that I told you, you need to memorize 1 through 12, your perfect squares through 4, 1 through 12, because it makes it easy for you to identify. I know that 25 is a perfect square. 25 is the perfect square of 5 times 5. Okay. I also know, but that's the number is perfect square there. But I also know that 4 is a perfect square of 2 times 2. All right, well, that lets me know that this on the left side, the left expression, is a perfect square trinomial because 4 is 2 plus 2. Okay, my C adds up to my B term. So now I'm going to rewrite the left side as a factored form. So I'm going to say x plus 2, and I'm going to square that, and that's going to be equal to 25. Okay, so now I'm going to take the square root of both sides. All right, now here's where you need to be careful. The left side, the square roots cancel each other out, so this gives me, the square and the square root cancel each other out, so it gives me x plus 2 is equal to, now, whenever we take the square root of a number other than 0, we need to take the positive and the negative. So this is positive and negative 5. Okay, so now that lets me know, well, when I solve for x, because again, I'm solving for x, so I'm going to subtract 2 from both sides. So x is going to be equal to positive 5 minus 2, or x is going to be equal to negative 5 minus 2. So that's going to give me x is equal to 5 minus 2 is 3, or x is going to be equal to 5 negative 7. So my answer is going to be negative 7, 3. Okay, let's do one more.